In this question, we're asked to use algebra to prove that 0.136 recurring multiplied by 0.2 recurring is equal in value to 1 over 33. So the first thing that we can do is start by writing 0.136 recurring as a fraction. So now let's write out 0.136 recurring like this. So let's say that x is equal to 0.13636 ... Now we can say that 10x then is equal to 1.36363 because we multiplied both sides by 10. And now let's do 100x. 100x equals 13.63636. And finally, let's find 1000x. And we can say that 1000x is equal to 136.36363, and so on. And so what we were doing here is trying to find a way to eliminate the numbers after the decimal point. And so we were able to do this quite successfully. If we look at 10x, we have 1.36363, and so on. And then looking at 1000x, we have 136.36363, and so on. Now since we have the same pattern after the decimal place, if we do 1000x take away 10x, all the numbers after the decimal point will disappear. And so we can do just that. So 1000x take away 10x is 136.36363 take away 1.36363, and we're left with 135. And so 1000x minus 10x can also be written as 990x. So we can say that 990x equals 135, and simplify this to get x is equal to 135 over 990. And now looking back at what we did earlier, x was our original fraction. We said that x is equal to 0.13636 ... which is exactly the fraction given to us in the question. And so we've written 0.136 recurring as 135 over 990. Now let's move on to 0.2 recurring. We can write 0.2 recurring as 0.22222, and so on and so forth. And so we can do the same as what we did before. Also, x equals 0.2222. We can therefore say that 10x equals 2.2222. And so since we have the same numbers after the decimal point, we can do what we did earlier and say 10x minus x equals 2.2222 take away 0.2222. The numbers after the decimal point will cancel out, and we're left with a value of 2. So 10x minus x can also be written as 9x, and so we can say that 9x is equal to 2, and therefore x divided both sides by 9 is equal to 2 over 9. And so we can now say that 0.2 recurring, written as a fraction, is 2 over 9. Now the final step in this question is to multiply 0.136 recurring by 0.2 recurring, and to get a value of 1 over 33. So we can do 135 over 990 multiplied by 2 over 9. And so we can multiply the numerator and we can multiply the denominator, and so we end up with 270 divided by 8,910. And if we put this into our calculator, we can see that this simplifies to 1 over 33. And so we've now proven that 0.136 recurring multiplied by 0.2 recurring is equal in value to 1 over 33. This question is worth 3 marks, so let's take a look at where these marks are allocated. The first mark is for a process to find 0.136 recurring as a fraction, which we showed clearly on the right hand side, and we proved that 0.136 recurring is equal to 135 over 990. Now the second mark is for a process to find 0.2 recurring as a fraction, which we've clearly shown, and we ended up with 0.2 recurring is equal to 2 over 9. And that final third mark is for doing the arithmetic to find 135 over 990 multiplied by 2 over 9, and for proving that this value is equal to 1 over 33.